So this is my 6.3 numerical model by Harry Baker. So kinetics is the force involved in the movement of an object or body. It's split into two sections, which is linear kinetics and angular kinetics. Linear kinetics involves rectangular and curvilinear, and its force, gravity, mass, weight, and therefore angular rotation is specifically levers. Kinematics is the study of motion of a body or object, so the change in position. It's divided into three sections: linear motion, angular motion, and general motion. Linear motion is a straight line, or it could be curvilinear. Angular motion is around an axis, and general motion is linear and angular motion together. So linear motion involves all parts of a system moving the same direction at the same speed. Rectilinear motion along a straight line, and curvilinear is along a curved line. An example of linear motion is skydiving. So angular motion is a system that moves in a circular path around an axis, so all parts move through the same angle in the same direction at the same time. An example of this is a shot in basketball. General motion is a combination of linear and angular motion, most common in human movements. An example is running. So numerical model production. So to determine the perfect technical model, you could watch an elite level performer, read literature, for example, a booklet given on a coaching course, read leaflets. It could be specific athlete based, or the combination approach, which is a mixture of all of the above. So advantages and disadvantages. So there are many advantages and disadvantages of the numerical model. Some advantages include biomechanics can help elite athletes. It also helps to identify weaknesses, so changes can be made to improve. You can model successful athletes, and it can help reduce injury. However, some disadvantages include it's a very complex process. It's very mathematical. The depth of theoretical knowledge is needed. Controlled environment is needed, specialized equipment, and it's very time consuming and expensive. So scalars and vectors. So scalar is a value that has a magnitude, how big, fast, or far. An example is distance, speed, mass, or inertia. And a vector is a value that has a magnitude and a direction, however fast, up or down. An example is displacement, velocity, acceleration, deceleration, weight, or momentum. So speed and velocity. So speed is how quickly a body moves. It's the rate of motion. It's measured in meters per second. As you can see in the equation, it shows that the average speed equals the total distance divided by the total time. Velocity is how quickly a body moves in a resultant direction. It's measured in meters per second with a direction against. Again, the equation shows the average velocity equals the total distance divided by the total time. Distance and displacement. So distance is the sum of all movements regardless of direction. For example, the route an athlete or object takes as a value. And displacement is a straight line distance from point A to B in a particular direction. It refers to a human or objects. For example, the direction, a route as a value, and the directional value. To work out the displacement is the difference between an object's final position and its initial position, as you can see in the equation. An example for distance and displacement is a 4 by 100 meter freestyle in swimming relay. So the distance would be 400 meters and the displacement would be 0 meters as they would finish where they started. Also looking at the distance and displacement graph, we can see that it shows that the distance would be 14 and the displacement is from 5 to -5. So acceleration. Acceleration is the rate of change of speed and velocity, and it's measured in meters per second squared. Acceleration equals the change in velocity divided by the time taken, as you can see. Looking at the graph on the left, it shows the green line as the constant acceleration and the blue line as the negative acceleration. the change in angle of the slope of the graph equals the change in acceleration. Looking at the graph on the right of the acceleration time graph from Ben Johnson's 100 meters, it shows that the first 2 seconds of his acceleration was gradual, then after 2 seconds it's dramatic acceleration, and then it graduals out again until he reaches his peak around 6.5 seconds. Then he starts to decelerate. So graphs. So the graph on the left is a distance time graph. Point A to B is a horizontal line, which means that there is no motion. The point B to C, there's a positive curve which shows an acceleration. Then C to D shows a steady line, which means the speed is constant. And lastly, D to E is a negative curve which shows deceleration. Then the curve on the right is a velocity time graph. As you can see, from point A to B there's a positive curve which shows acceleration. Point B to C is a negative curve which shows deceleration. And then point C to D shows they're going at constant velocity. And then when the curve goes down below the x-axis, this means there's a change in direction. So inertia means the reluctance to change. So everything has an inertial value, and you have to do something bigger to change it. So force and the effect. So all motion is created by force. A force is a push or pull. It's not visible, as you could see the effect of force. A force acts on an object. So force is a vector. Magnitude and direction is required. They can be applied with or without contact. With would be friction and without would be gravity. It's measured in newtons and can be measured by force plates. There are many types of force, including an applied force, which is the type of force, contact force, that is applied to an object or by a person or another object. Gravitational force is the force with the earth or object attracts another object. Friction force is the force exerted by a surface as an object moves across it. Drag force is opposite to the direction of motion. Spring force is the force exerted by a compressed spring upon an object that is attached to it. Tension force is the force that is transmitted through a string or rope when it's pulled tight by a force acting upon opposite ends. Balance forces are two or more forces in opposite and are equal sizes and opposite in direction, and the forces cancel out each other and the net force is zero. And an unbalanced force occurs when a force is acting in the direction is bigger than the force acting in the other direction. So there are two types of force, which is vertical force and resistance. Vertical force, which are resistance and weight, and horizontal force, which is in swimming, for example, is the water surface and the drag force. There are also internal and external forces. Internal forces contract of the muscles, and external muscles could be external could be air resistance, friction, or gravity. There are 5 effects of force, which are a force, which is the first one. A force can cause a body at rest to move. The second one, a force can cause a moving body to change direction. The third one, a force can cause a body to change its shape. A basketball specific example, fourth one, a force can cause a moving body to decelerate, and the fifth one is a force can cause a moving body to change its shape. So a basketball specific example for the 5 effects of force related to what I've just said. So the first one could be at the start of the game where the tip off and fast break. The second could be offensive to defensive transition. The third could be a fast break where you lean forward. The fourth could be where you get to the end of the court and you have to lean back to slow down. And lastly, the fifth one could be when you catch the ball with your fingers. So Newton's laws of motion. So the first one is inertia, which is reluctance to change. So every body at rest or moving with a constant velocity in a straight line will continue in that state unless acted upon by an external force exerted upon it. So there can be a balanced force in a motion with zero net force. The second one is acceleration, and the acceleration of a body is proportional to the force causing it, and the acceleration takes place in the direction which the force acts. So mass tends to have a constant value. Acceleration is caused by rearranging the equation F equals ma. The third one is action and reaction. So every action there's an equal and opposite reaction. So if you push down on the ground, for example, when running, the ground will push back up and exert an opposite reaction and push you up and forwards. So different forces and eccentric forces. So the force's direction that is being applied, consider a centre of mass, will help decide if the motion is linear or angular. So if the line of force is through the centre of mass, the motion will be linear, which is direct force. And if the line passes outside the centre of mass, the motion will be angular, which is an eccentric force. And eccentric means not placed centrally, and specific to the area of the force is the type of motion. So impulse. So impulse is another way of describing force. Impulse is concerned with the length of time a force is applied to an object or body. So as you can see, the impulse equation is the force times the time. Momentum is the amount of motion possessed by a moving object, and it's produced by the produce of mass and velocity. In the equation for momentum is mass times velocity, and it's measured in kilograms per meter per second. So a basketball specific question that relates to momentum is if a player is running for a rebound that weighs 90 kg and the player has a velocity and they have a velocity of 8.5 meters per second, what would the momentum be? So to work this out, you would times the two together, which gives an answer of 765 kgms. So the conservation of momentum is about for a collision occurring between object 1 and object 2 in an isolated system. So the total momentum of the object before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum is lost by object 1 is equal to the momentum gained by object 2. So the relationship between impulse and momentum. So as you can see, force times time equals impulse. However, you can have a smaller force and a longer time to get the same impulse, or a smaller force and an increased time to get the same impulse. The relationship is the force generated from the impulse will impact the force, motion, and momentum. So if you wanted to change the impulse, you would have to change the momentum. So in a vertical jump, we want a bigger force, which means the velocity needs to increase for a bigger jump. Also in basketball, if you want to shoot further away, people tend to bring the ball lower down to generate more force, which means there'll be a bigger change in momentum. So stability. So stability relates to how difficult it is to disturb a body from a balanced position. Stable objects are very difficult to topple over and move. Factors that increase stability are lower the centre of mass, keeping the line of gravity within the base of support, widen the base of support, more points of contact. An example of a sport that needs good stability is rugby, so the players don't get knocked over. For a rugby player to increase their stability, they lower their centre of mass and increase the width of the base of their support. So instability refers to a lack of stability where the centre of mass moves outside the base of support. An example of where instability is good is in when a gymnastic creates instability to initiate a cartwheel. Another example is diving as they lean forward to reduce the base of support, and as they are falling, the reaction force goes straight up. To reduce stability, you do the opposite to what I said earlier. So you make the centre of mass higher, make the line of gravity outside the base of support, reduce the base of support, and have less points of contact. So centre of mass. So centre of mass refers to a point at which the body is balanced in all directions. Gravity acts down against the centre of mass. As you can see in the picture, the red dot is the centre of mass for each position. A good sporting example for the centre of mass is high jump, because the old technique required the centre of mass to go over the bar like the scissor kick, but the new technique which is the Fosbury flop, which means the centre of mass can be below the bar. So as you can see in the top right picture, this allows the athletes to jump higher as it's more efficient.